Okay, I think it's recording, so again, hopefully this works. If not, it almost happens every year. I have at least one that fails miserably, so this might be the one. So I guess if you're watching this, I guess it worked. And if you're not watching it, well, sorry. But obviously, you didn't even hear me apologize. Okay, so here we go. Something old, but maybe not as well covered in INFS 1101 as what we need. This is what I've discovered, because if I ask the students, have you seen this, they'll ever say yes, but then there's always a whole pile of misconceptions going on, so yeah, this ends up happening. Oh, by the way, I also have to remind you of one quick thing, just now that I think about it, and I am recording. Okay, yes, sometimes things do happen and I got to change the syllabus. I did say that we would change it, so I'll just let you know the update. It isn't very significant. Okay, there's one little significant thing. It's just a date, but I will point it out. That's what I said. You'll notice now that it is version 2. All right, so what I've been able to do is I've managed to get a confirmation of the room time for the lab exam and for the midterm. Okay, the midterm will be held on February 28th. Initially it was the 21st, sorry, that actually should have been a week later, because otherwise it makes no sense for me to have a review after the midterm. I actually meant the 28th all along. So now that has been fixed, I do have an actual time. It will be 11 in the morning, 2 hours. And likewise, the lab exam will also, I'll hold it at exactly the same time, 11 to 1. That way you don't have to get up super, super early, because if I had it at 8, everybody would be really upset with me. All right, so those are the only changes that I had to make to the syllabus. So sorry I had to make it, but that's the rooms. I've got them confirmed now. All right, back over here. All right, so here we go, functions. Yes, I am quite keenly aware that you have seen functions before in INFS 1101, but as I said, I find sometimes that there's a few concepts that are not quite as clear as they should be. So what I do today is I pick something. I'll toss in some new stuff that you probably haven't seen. You'll actually see these in the lab next week as well. And then on Wednesday's class, we will do something, again, which I know is only being very lightly covered in the other course. All right, a couple of textbook sections, big deal. All right, so real life problem. All right, you want to go off and you want to buy a car. Most important thing, how much do I have to pay? Now, of course, there's two options when you want to buy a car. You just pay for the thing outright, and that makes it pretty easy because you just look at the price tag and you go, oh, it's this much compared to this much, no problem. However, not everybody always has like all of the money to buy a brand new car all at once, right? So you take a loan, or you consider at least taking a loan. And in order to take a loan, you're going to have to know how much do I have to pay back each month. All right, well, there's a formula for that. It's right down there. It says M is equal to P times R multiplied by 1 plus R to the power of N divided by 1 plus R to the power of N minus 1. Nice and simple formula, right? Okay, well, for the people taking the FinTechs course, hopefully this kind of shows up something straightforward. But if I gave you a calculator and I gave you the formula, could you calculate it? Yeah, and the answer is sure. But it's a pain in the neck because it's a whole bunch of calculations you have to, especially if you don't have parentheses and say all that you had was just a very simple, basic arithmetic calculator, you're probably going to find it to be a little bit of a pain in the neck. However, if you happen to contain some really, really fancy or happen to own a really fancy calculator where a bunch of finance calculations and formulas are built in, it makes life really easy. For example, I found this old HP calculator, and you can see buttons on here like PV for present value. Yeah, that's going to be this one right here. PMT would be the magic button for the M. The R would probably be the I, and the N is probably still the N. So the idea, you learn how to do this, you type in a couple of buttons and you say PMT and it'll tell you how much. Now, that obviously makes things a whole lot easier when you have that button. And that's the whole idea behind a function, is you want it to be as easy as pressing one button, not recreating everything. Okay, but unfortunately in this course, we don't use it this way where we say, okay, here's a big long function, just use it. No, what we do is we make you write the functions because it's the fundamental building block of absolutely everything we do. I've talked many times already about the size of real programs. Okay, I mean, the programs you're writing here are useful at times, but they're certainly not real. And what I mean by that is, yeah, they don't have enough features, they don't have enough options in here to be really useful to everybody. They're useful maybe for helping you with some things, but if you were to put together, say, a real application, such as, well, we've got PowerPoint running right now, the number of lines of code is, I'm guessing it's like 500,000 lines. Now, I know at the moment, if you think about 500,000 lines, you go, wait a minute. Imagine 500,000 lines in one file. You're trying to figure out where things are. You know how confusing that would be? Yeah, absolutely. That's because nobody develops programs this way, because it's too much. It's too much for even good people. You see, even me, once you happen to go beyond about 50 or 60 lines of code, things start to kind of fall apart, and that is, you can't keep track of what's going on, because if you have a lot of variables, you say, wait a minute, was it this variable or that variable? You're constantly scrolling around. So what programmers do is they subdivide their problems into smaller, more manageable chunks. In the world of 1201, what we end up doing is we introduce the concept of functions, so that what we can do is we can break things up into small pieces. Usually these functions are not more than about, say, 20 lines. Even in a real program, if I showed you some of the functions I wrote, you might say at one point, oh, that's 50 lines, but it probably doesn't get much larger than this. Okay, so the whole idea is, how do you make the buttons on this calculator? You already know how to do this, by the way, sort of. Okay, so I'll put something into context for some of the students. Everybody here has probably used the SQRT function at least once, okay? Because I usually get the people to do this in the lab. All right, if you have taken calculus, okay, so math 1030, so I know it won't be everybody, but if you've taken calculus, you would know how that little square root function works. Because if I ask you right now, okay, give you a regular calculator, can you calculate the square root? And you'll probably say, no, I don't know how to do that, because I don't know a formula. Well, it turns out it isn't really a formula, but it's an iterative process. It's something called Newton's method. So if you've taken 1030, you would learn about Newton's method, and that's actually what the calculator does. But what our math.square root does, it actually performs Newton's method, and it performs it very, very quickly. But all of that detail is hidden from us. That's why we use these. All right, so as I said here, if you had to do this without a really cool little calculator with a PMT button, and you had to do this 3 times because you're trying to figure out, do I take this option, or do I take this option, or do I go over and I take a completely different car based on interest rates and length of payment and so on, what's the best thing for me that I can actually afford? Trying to do this calculation over and over time is actually going to be a bit of a trouble. All right, so let's write a program for it. Hello. Okay, did it stop? Okay, perfect. So we've actually got the program, so I'd rather bring the thing over so we can at least run it and look at it. And we're going to talk about this. We're going to build up a little storyline. Okay. So here we go. This is the program I'm going to use today. Sorry, it doesn't quite fit on the screen because of the size of the font, but it's okay. I don't think you have to really see the end of it. It's just syntax. I'll scroll across. All right, so what does this program do? All right, well, it asks for how many years we're going to have the loan, what's the interest rate. The formula, by the way, needs to be put in a month, so I had to multiply by 12, and the monthly rate had to be, with a bit of a calculation, to be divide by 12, divide by 100. And then you can see what I've done is I've gone in and I've put myself into a loop for, well, 3 times. Because we have 3 different cars, we want to actually see what the best possible price is. All right, so how many years for the loan? So maybe you're thinking, okay, 5, maybe the interest rate is now in percentage. So I'm guessing I can say something like 6%, and now you can just type in different amounts. So maybe you're considering, everything is really expensive now. Okay, what have we got? Maybe like Nissan, I'm not sure which one, probably not a Sunny, wouldn't be that expensive. But anyway, so this one comes up as $1,353 per month. Maybe you're considering buying something that's a little bit bigger. Let's see, this one, that's probably almost the price of a Camry these days. Okay, that's gonna be $3,000. And if you're looking for a very high-end Land Cruiser, maybe it's $500,000. Not sure about these, but there you go. So it's $9,000 per month. Okay, good. So we've done our 3 things. Now, why would I be interested in looking for 3 of these? Well, perhaps what I want to know is which one is the smallest. Oh, we did this last week. Okay, we did this last week as one of our exercises. You see, what I could do is I could modify this program by having something called the smallest or the least, and I can make it equal to a really, really big number. And then just after this, I can add questions like if the smallest, or sorry, if the payment is less than the smallest, and then you can make the smallest is equal to the payment, and then somewhere at the end you can print out which one was the smallest item. There we go. All right, so yeah, finding the minimum. All right, so you know what, just, you know what, for fun, we'll leave it in here. Okay, there we go. I don't need to run it, okay? I assume that I've not mistyped it. If I have, oh, sorry, you can fix that and run it yourself. But here you go. So we've got ourselves a little bit of a program. Now, it's not terribly difficult because it isn't really big. It's only 15 lines, but I think we can probably make it a little bit better. In particular, this line right here. Okay, or sorry, this block of code right here. Yeah, it's a loop, and what I'm doing is I'm asking 3 times for this, all right, and I'm calculating things, and I'm figuring out which one is the smallest. We can print it at the end to say, hey, this is your best option, all right, but maybe what we want to do is modify things a little bit. Okay, so first of all, okay, I've got a slide, so I might as well bring it up. All right, so what is a function? A function is simply a block of code that's defined to solve a very, very specific problem. For example, calculating your monthly payments on a loan. That's a really good, very specific problem to work out. In order to create a function, you need to define it, which of course means to write the code, and you need to make, and in order to actually enact on it, you have to call the function. And the whole idea behind having functions is it was supposed to stop you from having to copy and paste things. Unfortunately, it's not something that we do in this course very much, but in a really large program, if you're doing the same types of operations in different parts of your program, a better option is to have it in one block of code where everybody sends you back to one block of code so you can fix it in one spot. Unfortunately, we just don't get to see that much here. It does make your code easier to understand, and I can demonstrate that today. And most important, okay, what I've said before, in INFSC 1101, we heard the word problem decomposition, but then of course it went completely silent and we never explained ever again what that was. Generally what we end up doing when we're decomposing large problems is we like to use a lot of functions when we're designing large pieces of code. Now, designing code by creating your own functions and deciding what's going to go into the functions, that's a higher level of thinking than what we do here in this course. In this course, we actually make it very simple where we say, you must create a function that does this, and that's it. And you must create a function that does this. You're not making those design decisions, you're simply implementing or applying your ability to solve problems within this. Okay, but in terms of when we actually solve problems, yeah, nobody ever tells me you need to write a function for that. I just do it. There must be a reason. Yeah, it's to help organize code a lot better. All right, so now in terms of defining functions, okay, well, let's do it. All right, so what I'm going to do is I'm going to make version 1 of my program. It's going to be incredibly, incredibly simple, and it's not even going to solve the problem, but eventually we'll get there. All right, so you already know from INFSC 1101 that you can define functions. So this is going to be my very own function. So, and once you define your own function, you can call it to do whatever you want, and I'm going to call it loan payment. Okay. All right, this is obviously not a loan payment. I'm just putting print statements because I like to run things in small chunks just to make sure things are working. All right, so there we go. That's my very own function I made up. It didn't exist anywhere else until I typed it. What does it do? Well, supposedly it calculates a loan payment. It doesn't actually calculate a loan payment yet, but eventually it will get there. All right, well, let's clear the output, and I'm going to ask something very, very important. If I execute this program, what do we see? Oh, very good. That means you guys have learned this. Yeah, it shows absolutely nothing. When you define a function, you're not actually making it happen. You're simply saying that there is a function, it could be used. You see, just like, already built into Python, there's a square root function, but have we called it? No, so therefore it didn't actually execute. To call a function, pretty simple. Well, it is relatively simple. What you do is you write the name of the function, and you put a set of parentheses. Very, very important. All right, so this one right here, just to, no, you go away. This one is always jumping for my attention. All right, here we go. When you run this, yeah, you see, now we see this because now we're saying, hey, please call the function. All right, and what if I do this? Yeah, you'll see it 2 times because I call it twice. The first time it says this is a loan payment, then I call it again and say this is a loan payment. Excellent. So if I want to call it 3 times, all I have to do is copy and paste line number 6 an extra time, and now it will happen exactly 3 times. Perfect. So yes. Yeah, we can certainly use a for loop. That would probably make life easier. Okay, we'll do that after. Okay. All right. For right now, I'm going to do this because we have other problems. It doesn't work. Okay, so when you say something doesn't work, remember there's a whole lot of things that could end up happening. It could be a syntax error, it could be a runtime error, or, well, I mean, the doesn't work could be almost anything, right? Okay, so what do you think? Syntax error or runtime error? Syntax error. Okay, how are we going to know? Here's what I'm going to do. I'm going to stick a print statement just at the very beginning. If I see the output, we know that the program ran. Okay, and if we don't see it, it was obviously a syntax error. Okay, so let's find out. At least this way we know. All right, so let's go ahead and run it. And oh, it's a little bit strange, isn't it? It ran, but it wasn't an error. Yeah, unfortunately, that is not actually an error. It doesn't actually call the function. All that you're doing is you're saying, yeah, there's a function out there. What can you do with this? That's outside the scope of this course. Okay, that's the best way for me to describe this. So remember, if you want something to be called, you do this. If you break the syntax rules, okay, well, that's a syntax error. And of course, the syntax rule is, yeah, if you have a left parentheses, you better have a right parentheses to go with it. All right, excellent. So that's the first piece. All right, I don't need the word starting here anymore. All right, let's go and fill this in. So how do we do a loan payment? Okay, well, I hope you remember this code right here. Sorry, I'll just copy and paste it. You don't need to see me type it. There we go. So in the magic of time lapse, I have now typed a whole bunch of stuff really quickly. What does it do? Well, what it does, it says this is a loan payment. Okay, that print statement is just for my purposes so that I know that it's happening. All right, next thing up, it will ask for the years, it'll ask for the rate, it will do calculation of months, it'll calculate the monthly rate, it'll calculate the principal, the payment, and it will do a print. Oh, it's all the stuff that my other program was doing. Okay. Am I actually making use of the function? And the answer is yes. I've defined it, and I am calling it. All right, so we run it, and yeah, okay, so you see here it's asking for something. So 4%, 60,000 just for some numbers. So there you go. Oh, but it only happened once because I only called it once, of course. Yeah. All right, if I wanted it to happen 3 times, somebody suggested a few seconds ago 4. Okay, we don't know. Keep going. Oh, for I in range. Oh, do you know how much I hate the word I? Anyway, so I in range, we'll talk about this in a second. I'll give you some ideas. If we want it 3 times? 3. Yeah, just 3. That's pretty simple. And yeah, you do this. That's it. So here you go, 5 years. Okay. Oh, now it's asking, of course, for the number of years again. 54 year. Oh, so take a 54-year loan. It might be able to get the price down. Okay, 7%, $500,000. So if you can convince the bank to give you 500,000 reals for a car on a 54-year loan, you'll still have to pay 2,900 a month for 54 years. Sound like a good deal? No, you probably don't want to do that. Anyway, so here we go, 5 years, 7%, 200,000 or something, just so we finish this up. And there we go, now the program is finished. Okay, now, have I gained anything from this? Little tiny bit, not much, okay? It's only a very, very small amount. And for this, I have to use some sleight of hand. All right, and let's put it down this way. All right, the code that's not inside the function is usually referred to as the main body. Okay, it's called the main body. So here, I'll even write this one down just so you know exactly. Main body. The reason why they call it the main body is because back in the earlier programming languages, you always had a function called main, which started everything. Okay, so when you run the main body, based on this, what does it do? It figures out a loan payment how many times? 3. That's easier to read than the first version because the first version had all this other stuff going around. That's the only thing that I've gained. Oh, the complexity is just kept somewhere else. Well, that's okay because if you're just interested in what is the program doing, right there. How is it doing it? Well, that's all the details up here. But what it's doing, that has simplified. This is the whole idea behind why functions were created so that I can make the program obvious what it's doing. Okay, that's the reason why we have functions. Now, the problem with my function at the moment is it's not very flexible. Like for example, every time that I run it, I keep getting asked for the number of years. And well, I mean, if you're calculating something out, maybe you don't want to be continuously asked for all of this information, like the interest rate and the number of years. You just want to try different prices to see what you can afford. Okay, so this is going to be one of the things, but the overall program is very, very simple. It makes it really, really clear. All right. And the other problem I have is it says that it's the payment for the car. Well, what if I want to buy a boat? It's the same formula, but this function is not just a general law, it's just for a car because it actually prints them as each payments for this car will be. And really, if we go to something different, it's not really going to make any, it's really going to be the same formula. We just want to, we want it to be a little bit more flexible. So I've got 2 things that I'm going to do. It's not going to solve this problem directly, but I would like to pick up one thing at a time. All right, the first thing up. The amount that's right here called the principal, okay, this is the actual amount. Okay, this is the actual amount. Where does this come from? Well, right now it's an input statement. Okay, rather than asking for the price of the car here, I'd like to do something a lot different. I'm going to take this and I'm going to put it right here. Okay, I'm going to put it here. So it's no longer part of the function. But the problem is that obviously the function, which is right here, this is the actual thing that does the calculations, I need the principal. Okay, I need the original amount for the car. In fact, what I'm going to do is I'm going to call it the car price. So this value needs to somehow or another be given to the loan payment function in order for anything to work. So what I'm going to do is I'm going to add it as something called a parameter. I'm going to call it the principal because in the formula it actually is principal. So what I'm going to do is I'm going to pass in whatever the user typed out here as the parameter. So here we go. What I'm going to do is I'm going to say car price. So here's the way how the program works. The program reaches line 15. You know it's going to happen 3 times. It reaches line 16, waits for the user to type in car price, and then I'm going to call the function. But when I call the function, I'm going to pass in some information, which is the car price. And the car price, or sorry, the value up here called principal is going to be the same car price that was just passed in. This is providing data from the main program into a function. It's called a parameter. Officially, this is the parameter. This thing right here is actually called an argument. Okay, I've got to cover that because it is the correct nomenclature. A lot of people, probably a lot of instructors will probably call this a parameter and this a parameter. Okay, obviously I have to let that one go. But take a look at this. You see what I've done is I removed the question about the price of the car. Okay, let me run it just for a second. I haven't really improved the program very much. So here's the price of the car, $50,000, all right, for 4 years, and the interest rate of 5%. Okay, it seems like a reasonable number. And then of course it says price of car again. So yes, that number was passed in and now the function works with it. So I mean, it's kind of cool because you see, if I want to ask for, if I wanted to have a different one for a boat, no problem, now I changed it here. Notice what I didn't have to change? I didn't have to change the function. Remember what I said, the whole purpose of these functions was you write it once and then you don't have to change it. You can use it in different contexts. In fact, often what people will do, and I do this all the time, I will write a function and then I'll copy and paste it into another program because it's doing the same thing over and over and over again. All right, but the problem that I have right now is, okay, that's the car price. But remember, there's two more questions being asked, and that is, how many years are there, and what's the interest rate? Now, let's suppose that we don't care, and it's always the same number of years and same interest rate. Here, I'll show you something cool that we can do with this. Let's take these two statements, and instead of keeping it here, we'll cut it from here, and I'm going to paste it right here just before the loop. Now, again, take a look just at the main body. What's it doing? It's asking for the duration and the interest rate, and then it's going to ask 3 times for different prices, different cars, and it's going to print 3 different car prices. Oh, but of course, the issue is I have to somehow pass this in. So I will pass in years, and I'll pass in the rate. Now, what I'm going to do is I'm just going to change a couple of names in here. I'll just call this rate, just so I got different variables, because that becomes really important. All right, so this will be years, okay, and rate. And I need 2 extra things up here. I'll need something called years, and up here it's called annual rate. So that's the one that I have to use. Okay, there you go. Oh, wait a minute, they're not the same names. No, that's actually that's important. I'm doing this on purpose. They don't have to be the same names. Do people make them the same names? Unfortunately, they do. And I say unfortunate because sometimes you can lose out on the understanding about what's going on. You see, when you call loan payment, what happens is the car price becomes principal, the years becomes years, okay, and the value of rate becomes the annual rate inside the function. Okay, how does it know which one to put in? It's pretty simple. The first parameter goes to the first value, second parameter goes to the second value, third parameter goes, the first argument goes to the first parameter, we'll use the term correctly, second goes to the second, the third goes to the third. That's how you determine. It's exactly in order. Okay, and I'll demonstrate in a second. Okay, let's run it, terminate. I think I had some issues with that. Hello, wake up. All right, here we go. So how many years for the loan? Okay, so 5 years, 7%. Now, what it should do is it should only ask me just for the value of the car. So if you're trying to decide between a 70,000 versus a 100,000 versus 150,000, do you see what this is? Now I've made this program a lot easier to use, and it's actually a little bit easier to understand what's going on because now we're starting to isolate things. All right, a little bit further. Okay, I really don't need this one, but I'm going to leave it in. Okay, so it's pretty good, except I have one extra thing that I don't like so much about this one. This output statement is right here, okay? And that's fine. So the loan payment function gets called, it does its calculations, whatever it has to do. Maybe there's if statements, other things. Maybe there's loops inside here, and eventually there will be, and then it prints it. The problem is I don't know if it's for a car, for a house, for a boat, or a vacation, or anything else. So what I want to do is I don't want the print put here. You see, I want to be able to use the same function in other programs, and I probably don't want the message, payments for this car will be this. Okay, here's what I'm going to do. I'm going to rip this out, and I'm going to paste it right here. Okay, now here's the issue with this one. Payment. Okay, what do you think? Do you think it'll work? No, and the reason for it, okay, we'll talk about variable scoping next class. You see, right here, I've calculated a payment, but I'm no longer printing it. I'm trying to print it outside. And the thing is that once you leave the function, any variable that you created is now gone. It's scoping rules. We'll see this in next class. All right, so here's the problem is, okay, we've got this really cool idea. Oh, and by the way, this is pretty easy to understand. Well, okay, assuming you got the formula, it's pretty easy to understand what's going on. It's not what I often call polluted. It doesn't have any input, doesn't have any output. It really is just plain old straight everyday calculations, absolutely nothing else. Which means that I can take, especially if I remove this statement right here, you see what I can do now is I can copy this and I can paste it into any other program that needs loan calculations. Has nothing to do with whatever the program's doing. Maybe it's asking for 10 loans, finding the best rate. I have no idea. Maybe it's doing other things, but this is just a regular everyday function. It's kind of like SQRT. We can now just reuse it. And you can copy and paste it directly as is, no change whatsoever, and we can just use it for whatever problem we run into. But the problem is how do I get an answer back? Okay, to get an answer back from a function, and I know you've seen this, the magic word is called return. All right, now the word return does two things. Number one, it says stop the function right now, don't go any further. Like that makes sense because it's the end of it. And I'm also going to say, this is what I'm going to send back. So I'm going to send this back to the person who called. Now, the person who called needs to do something with it. And usually what they will do is they will store in a variable. And yes, I once again have used a different name, just so I can demonstrate that they are different things. So here's what happens. When the payment has been calculated, the function says, please return this. When it gets returned, the main program stores it in the PMT, which means that now I don't print payment, but I print PMT. All right, so we run this. Okay, here we go. 5, 6. Now we can try the different amounts. Oh, okay, it happens. Okay, PTM. All right, PMT. All right, here we go. 5 and 6 and 500,000. Oh, 50,000, okay. 60,000 and 70,000, so now you can compare these. All right, and again, notice what I've done. I have completely isolated the loan payment, okay? This is now completely reusable in other contexts. That's one of the big features or selling features of using functions, is so that you can have a piece of code that you can reuse in other places. Notice it doesn't ask about cars. It simply does a calculation, a mathematical application, exactly that formula. All right, got one little change to make because I have to remind you of something. Okay. Just wait, you guys are getting a little too noisy. All right, sorry, I've got one extra thing that I have to do because there's going to be a bit of an issue. Let me just check and see what version 3 was. What else did I do? Okay, I've actually made it that far. Wow, I might be done early today. I didn't say that. Okay, if we finish early, that's excellent. I can always find stuff to talk about. Usually it's a bunch of bad examples. Okay, excellent. So we need to come up with some slightly sketchy examples now. Okay, principal, years. Oh, okay, years makes sense because it's the same. Does anybody have any idea what would happen if I were to remove this from here and paste it here? Okay, so number one, we could have the possibility it's not going to run because of a syntax error. What do you think? No. Yeah, it's valid syntax. Okay, it's going to be a runtime error because when I try to call, I'm going to realize that, oh, wait a minute, no, he passed it rate because it's supposed to be principal, years, rate, and instead I got rate, price, and years. No, that's also, it's not going to determine any type of problem here. What it's going to do is it's going to continue on and it's going to calculate the payment based on probably something a little bit ridiculous. You see, what's going to happen is the rate 5 is going to become the principal amount. So basically so I'm going to run this just so we can talk about it. So you see, this is going to be the number of years. That's going to show up as the annual rate. So it's going to be a 5% loan. Let's see, the interest rate at 6, that's going to go in as the principal. So it's a 6 real loan for 5 years at the interest rate of $500,000%. Oh, okay, well that's actually really good. This created an overflow error. That's cool because I haven't seen one of these actually ever during this course. I'm glad I tried that. All right, an overflow error means basically you created a number that was so massive that it couldn't show. Yeah, so in other words, I mean, that must be a really big number. So we must be talking trillions and trillions of real every month for a 5 real loan. Yeah, but I mean, that is actually how it calculated. Okay, so something very, very important. The order that you're passing things in has to be the order that you're looking for, right? That's a guaranteed rule. Okay, I'll change it in a minute. All right, here we go. Let me put it back for a second. All right, for this to work, the original car loan has to be put in place. So here we go, car price, it has to be the number of years, which I did call years, and here I called it rate. Okay, good, so we're back in operation, we've undone our work. We've got more problems. Lots of murmuring today. Okay, this one. Okay, looks like a problem, right? Okay, so describe to me the problem. Besides, because if you ask me how come this isn't working, I'm going to tell you this statement, so you better know it. Yeah, because you're passing in 2 arguments, but the function's expecting 3 parameters. Okay, very good. All right, so of course what we have to do is we have to find out is it a runtime error or a syntax error. What do you think? Okay, good, I got both, excellent. All right, let's try running it. It's a runtime error. It's a runtime error in Python. If this was Java, it'd be a syntax error. It'd be treated like a syntax error because you'd say, no, you're not allowed to do this. The problem with Python is it's very, very lazy when it does things. It just waits till the last second. Oh, it sounds like people doing work, right? Just wait till the very last second. I know I've got this assignment coming up. I could have done it 3 weeks ago, but it's due in another 20 minutes, so I'll do it now. This is exactly the same model that Python uses. It waits till the absolute last second. So 5 years for a loan, 6%, 100,000. And at this point here, bang, it blows up. The error is pretty decent. Okay, that's the one nice thing about this. Loan payment missing 1 required positional argument annual rate. Okay, so you go and you look and you go, okay, right, there's this one right here was missing. Yeah, okay, pretty simple, right? Okay, let's start making some adjustments to this. And sorry, these are the things that I know are not exactly in the slides, but we're almost finished. I told you sometimes this ends up happening, so I'm trying to embellish, just add a couple of extra things. I know that there's some stuff coming in the labs next week, so better if I cover it now, and that way it's out of the way, and that way when you get there you don't go, oh, I didn't know this. Yeah, you can still say that next week, but at least I know I've covered it. All right, I want to type something new, which is incredibly weird, but here's the first thing. I hope that you've noticed I use a lot of print statements to see what's going on. Yeah, there's a reason for that. It isn't like just demonstration. No, this is the way I write programs. Okay? Does that mean that you should do the same? Well, I don't know, maybe you're better at writing programs than I am. Okay, if you are, then feel free to skip things out. Honestly, what I will do is I will constantly print things, and it's, honestly, I do this an awful lot. Okay, I'm just gonna print out the principal, the years, and the annual rate. I'm not even gonna print anything else, just to know what's going on. All right, so in other words, I run this, okay. Oh, okay, it's fine, it'll crash, I don't care. Here we go, so 5, 6, and 70,000. Oh, the loan payment, sorry, I guess I do need 1 extra because I put the print inside. Sorry about that. This is going to be the rate. Here we go. So 5, 6, and 70,000. All right. 70,000, 5, and 6. Those are the values that come in. When I'm writing a brand new function, I will often do this. I'll just print everything so that I know what goes in. Because if you're having a problem with this program, now we've got 2 parts. We have the function itself, and we have the person who's calling it. If something isn't working, where's the mistake? I don't know, maybe it's here, maybe it's there. Your job for debugging is to very quickly find out where's the mistake. That's always your job. I mean, okay, if you're in a lab, you can put up your hand, ask the instructor, what did I do wrong? And they might point you at something, but hopefully what they're doing is they're simply saying, well, how many things are you passing in? What are the values? And that becomes really important because, you know, sometimes people pass in the years and the rate backwards or in the wrong order. And that becomes really important. So printing it is very handy. Even if I don't let the thing run any further, just seeing what values go in, it's very useful. All right, so here we go. Something new, something completely new. I probably should have put the years at the end. Okay, but that's fine. Okay, I told you there'd be some new stuff today. I'm pretty sure you haven't seen this in infs1201. This is called a default value. Okay, the best way that I can do this is I'm going to run the program a couple of times and we'll make some changes to it so that you'll be able to pick up exactly what this means. All right, so here we go. Here's the first thing. Now, it looks really suspicious because, wait a minute, you have an assignment statement here in a parameter? Yeah. Okay, here we go. Let's run it. Okay. Years is going to be 5. Interest rate. Okay, it's a bad interest rate. It's 12. Okay, now, next thing it's going to ask is a price of a car. I'll put in 70,000. When I press enter, it's going to call the function. All right, now we'll go through this because we need to make some predictions about how this is going to work. It's going to print the principal. Remember, the principal is the first argument. So what's the car price when I press enter? Good, okay. What's the value of years going to be? That is the years. That's going to be 5. Okay, and then my question is what's this annual rate? Oh, good. So I got both answers, 12 and 7. All right. So here's the deal with this: is when you pass a value in, you're passing in the value. So what's the value of rate? It will be 12. So when you start this program, or sorry, start this function, the annual rate is going to be 12. Okay, so there's nothing weird about this. Then what's the point of the 7? Okay, we'll get there in a second. All right, just to prove, there you go, 70,000, 5, and 12, exactly as you want. Now you've got the different things. So if you want to take a loan for 5 riel from the bank, they will charge you 0.11 QR per month for 5 years. At least I think we can afford that one. Okay, maybe. Unfortunately, you're not going to buy very much of a car for 5. All right, but in any case, here we go. We've got this. Now, what was the point of this? Okay, here's the point. Okay, we were just here a minute ago. What's the problem with this? I'm not passing in enough parameters. Yeah, okay, good. So in other words, when we run this program, okay, we'll ask for the 5, we'll ask for a different value, ask for an 8 this time, all right, and we'll ask for 50,000, just so it's completely different than any other one that we've done. When I press enter, I have to start asking questions. Okay, number 1, maybe it crashes because, well, we're missing, okay, but watch this. When you run it, it just goes ahead. Okay, so now let's look at this. The principal was 50,000. That makes a lot of sense. It's 50,000 because right here was the car price was 50,000. The years was 5, and that's because that's what we passed in. The annual rate, on the other hand, we passed nothing, so the function picked up the default value of 7 and said, okay, well, because they didn't provide me one, I'll just use it. Okay, oh, and by the way, this you've used before. You just don't know about it. You see, the print statement, you can add some extra things at the end to say that the end is equal to nothing, and that prevents the new line character from going on. It's actually using default values. If you don't provide one is provided for you. It sounds like something you hear in a TV show when the cops arrest people. All right, what that is, that's a default value. If the caller doesn't provide one, it picks up the default value. If the caller provides a value, that's the one that gets picked up. Okay, so whatever gets passed in is passed in, but if somebody forgets to include it, it comes in for free. Okay, it's automatically default to this. We use this all the time for certain things. Like, for example, if you're trying to calculate, let's see, when you're calculating fees here, I know you pay for a certain number of credit hours. What's the most typical number of credit hours that you have in a course? 3. I know this course is weird. So you get to pay extra for the fun of taking this course from me. Is your payment. It's my entertainment fee. Anyway, so what you could do as a parameter is you could say, well, the default number of credits is 3 because that's the one that most often happens. That's what we use default credit, or default credit. That's what we use default parameters for. All right, so there we go. There's the first one. Okay. Next one. Okay, the next one will completely cause all kinds of chaos. But we got it covered, and it is in the labs next week a couple of times, mostly about understanding. Oh, and by the way, we don't ask students to do this. Why? Well, okay, I sometimes ask them, what does this mean? Yeah, that's fine, using the form of trace question. But when you're designing your functions, you don't have to make a decision, what do I set this equal to for a default value? I tell you that, okay, because your job here is to write functions, not to design them. It's a different skill. All right, does this work right now? Yeah, why? It's missing principal. I need to have it. It's also missing years. And the reason why they're missing is because there's no default values. Oh, perfect. Stick default values for everything. It depends on the problem you're solving. All right, but let me do this because this will be great fun. Just so I keep it completely separate, I'm going to remove the default. So I must pass in 3. Otherwise, it's a runtime error. All right, so here we go. Ooh, not this one. Rate, car price, and years. Oh, we've been here already. Right, this just doesn't work, does it? Because what will happen is the value of rate will end up in principal. In fact, you know what? I think I'll stop this and let the thing run just to show you. So 5 years, 6%, 10,000. All right, and you see what happens is the principal shows up as 6 for the number of years, so for 10,000 years at 5%. Good, so if you take a loan from the bank at 6%, for 10,000 years, that's all it's going to cost you. But of course, you have problems paying that off because I'm assuming 10,000 years, your bank account might not be around. Well, you might not be around. All right, unless we find something we used to see in The Simpsons, the brain in the jar still connected to Montgomery Burns. Anyway, here we go. Let's see, price of cars. So what am I trying to do? All right, so this is a problem. Yeah, you can't mix up the order of the parameters. Until now. Okay. You see, if I was going to pass in the rate, which parameter should it go to? It should go to annual rate. If I was going to pass in the car, where should it go? Principal. Okay, and sorry, now I'm going to go off the end. This is what I don't like about these. And if I want to pass in years, yeah, years is equal to years. But it's years equal to, yeah, it's because it's, otherwise it'll pick up the last one. All right, here, let's give it a shot. So here we go. 5 years, 6%, 20,000. Ooh, okay, loan payment got an unexpected keyword. Print. It's your fault. 5, 6, 20,000. There we go. Take a look at that. You see now the principal is 20,000, the years is 5, and the interest rate is 6.0. Yeah, you can actually pass things in different order. If you don't like it, switch it up. But do people do this? No. Why not? Easy answer. It's always the standard answer I have with anything to do with programming. I always make the claim that programmers are incredibly lazy. So is anybody going to type those words? Annual rate is equal to, principal is equal to, and years is equal to? No, but they can if they want to. Okay, and sometimes if you have really long and complicated functions, sometimes you will do things like this. I do occasionally write this out when you know you have a bunch of parameters and you can't remember the order and you're too lazy to go look it up, but you know the names, which is almost never, but every now and then I do find this very useful. All right, so what this is called a name argument. The first version that I showed you was positional argument. That's the most common. So position simply means that parameter argument 1 goes to parameter 1, argument 2 goes to parameter 2. This version basically can pass them in whichever order you want. It's just, yeah, most people probably wouldn't use it. All right, and of course, one extra slide. Okay, we're getting close. You've actually been using functions all along. The print statement, if you wanted to implement the print statement yourself, it's at least 50 or 60 lines of code, and you'd actually have to know how to deal with files. It would actually be kind of complicated. And the same thing like these math square root functions. Yeah, they're big, long functions. They do some really impressive and cool stuff, but yeah, it just comes for free built in. If you're trying to use functions to modularize your program so that it's easier for you to understand, yeah, well, then you write your own. And, this one back here, because imagine now, here we go. Imagine now I wanted to find the smallest payment. Okay, what would I do? Well, take a look at this. I'd have the smallest, and I would set it equal to something really, really big. How big? Infinity is big. That would even be better. 9 is probably not, so here. There we go. You start with something really, really big. Oh. There you go. That's pretty big, actually. But it means that I have to bring in the math library. That's the absolute biggest number. That's bigger than anything else. Okay, and if you're in the lab earlier this week, float, double quote, inf, it also works the same way. All right, so here we go. I'm going to start with something really, really big. Instead of printing this, here, bang, gone. Okay, here's what I'm going to do. If PMT is less than the smallest, then the smallest is equal to PMT. Okay, and at the very end, we'll print out a message like this. The cheapest monthly payments will be smallest. Okay, let's give it a shot. Oh, that's a terrible one. Here we go. Forgot this one. All right, how many years for the loan? Okay, 5 years, 7%. All right, 34,000. I'm still printing stuff just for testing. There you go, and 700,000. You see, I'm not even printing out anything else. I'm simply showing you the absolute cheapest. Okay, and again, just go back and take a look at the main function. If I were to take the loan payment code, which is those formulas, and put it, where would I put it? I would replace line number 18 with with at least 3 lines of code. Yeah, it would make the program a little bit bigger, but notice what this is. What does it do? Ask for the price of a car, compute the loan payment for the car, and figure out if it's smaller than everything else. It simplifies the main program. That's the whole idea behind functions, is trying to simplify things. All right, so 256. Okay, yeah, I actually still have time, by the way. Don't leave. Okay, somewhere in here I've got one of these things, so we might as well do it. I've got something called function flow for a Kahoot, so we might as well do it. It's only 4 questions. It shouldn't take very long. And you know how easy these things are. Nobody ever makes mistakes on them. Okay, and I've already learned that I've got a limit of 44 people, so if you're sitting beside somebody, maybe you can work on them to get more people in. How are we doing? 32. Okay, there's enough room for a few more. What have I got? Okay. What do we got? 44. Okay. I can't bring up any of the annoying music today, so I think that's fine. All right, let's go for it. That's a full thing. They want me to pay money so I can host more and get somebody else to pay for it. All right, so here we go, function flow. You know, they're always the same deals. It's what's the output of this program. I hope I've given you enough time. Sometimes I give like 5 seconds, which is not enough. Okay, 1 minute for each. Okay, hey, that's not bad. It's all about function flow today. There's the annoying sound, but it's better than silence. Ooh, that covers something very important which I haven't mentioned. Oh, but I did say it. I just didn't demonstrate it. Well, a lot of people have seemed to have gone for 1, 2, 3, 4, even without the comma. Anyway, sorry, I think the comma was a mistake. Let's see if we can find out why 1, 2, 3, 4. Okay, and there could be a mistake, by the way. Sometimes we have these problems. All right, so remember the very first line that happens is line number 6. Okay, because you jump to the main program. The definition is just a definition. What we do is we call the function, so we would print 1. Okay, good. So it's the first thing we start with. Oh, but they all start with 1. The next thing that happens is this return right here. Okay, I said it, but I didn't demonstrate it. When you reach a return in a function, it's finished. Doesn't matter what comes afterwards, it's finished. Okay, it's finished. It doesn't go any further. So from line 3, it will immediately go down to line number 7, and it'll print the 3. All right, at line number 8, it'll call the function again. It'll print the 1, but then it hits a return 12, and the return immediately makes it be over and done with. Okay, yeah, so that's why. Okay, but we had better than, at least it wasn't empty. Okay, let's give the next one a shot. Now we'll see the numbers after. There's 2 answers in here you shouldn't pick no matter what. See, I told you they're easy. Okay, which one? Okay. Only 3 people went after one that was absolutely, completely incorrect. That's good. We won't look up who it was. But, you know, the very first thing that gets printed is the 4. Remember, you're defining a function. It doesn't cause a print. It's only when you call the function does it execute. So the first number out is 4. So in other words, 2 options immediately go away. You don't have to look at them any further. All right, but here's what happens. First thing is 4. Then I call bad. Well, bad prints a 1. So 4, then 1. All right, but of course then we return. Then we call good. So then we'd end up with the 2. But then there's a call from bad, and yes, you are allowed to call a function from another function because sometimes you need to make your functions a little bit smaller by calling other functions. Trust me, it happens all the time. We've already done it, we call print. All right, so from a 2, then we'd end up with a 1, then you'd end up with 3, and then end up with a 5. Okay, so that's the reason for this one. Okay, so let's see, maybe the next one's better. I think everybody always gets this one. I have to make it harder. Yeah, okay. As expected, that one is pretty good. There's nothing funny about this one. You pass in a 10, A becomes 10, you return 11, you print it. Okay. All right, so note to self, make it better. Make it better for next time. All right, here we go. So one final one, we're done for the day, then you can go. And I hardly gave you enough time to do it either. Sorry, you should be in the full 60 seconds. Sorry, you got 10 seconds. No pressure. Okay, also note to self, I'll increase the time. Okay, more people got it. That's better. I think that's better than sometimes. All right, yeah, there's a lot of B's in here. Yeah, I didn't think of it until just now. I should have brought up some pictures of some bees. I'll add that. All right, so here we go. Here's the problem. Yeah, there's a lot of bees. How many bees are there? There's actually two. There's a bee in the function called 1, and there's a bee in the main. And they are completely separate bees. Okay, they're completely separate. So here's what happened. You see, B is set to 100, so I don't have 100 fingers that hold them up. Then what I do is I call 1, and this becomes B, or sorry, B is now 100. I add 1 to 100, so now B is 101. But I'm changing the B that's up here inside the function, and I return 5. And then I add 1 to it, and it gives me the number 6. Okay, yeah. Localized variables. This would actually work really well as a good lead-in into the next lecture, which is when you define variables inside a function and you have the same variable outside, are they the same or not? And at the moment it looks like no. Okay, but we'll cover when that isn't the case next class. Okay, thanks.